Good day, viewers. My name is Ode Godwin Daniel, and I'm your tutor for today. Please do well to subscribe and follow us across all social media pages at Gordon School of Mathematics. In today's class, we'll be looking at a very interesting topic, finding the subsets of a set using Pascal's triangle. Yes, using Pascal's triangle. Of course, you still remember how to draw Pascal's triangle, right? So let's draw Pascal's triangle together. Of course, we start with x raised to the power 0. Of course, according to indices, anything raised to the power 0 is what? 1. So to form the subsequent values, the next line, right? For line 2 now, we add the values for line 1 to form line 2, right? And then we'll add the values for line 2 to form line 3. We add the values for line 3 to form line 4, and so on and so forth, right? So the next value is x raised to the power 1. Now, nothing, the preceding number before 1 is nothing, which is 0. So 0 plus 1 will form 1, and then 1 plus 0 will give us 1. Now, to form the next one, which is x raised to the power 2, 0 plus 1 will give us 1. 1 plus 1 will give us 2. The 1 plus nothing will give us 1. Okay, so we have for x raised to the power 3, we have nothing plus 1 will give us 1. 1 plus 2 will give us 3. 2 plus 1 is 3. Then 2 plus 1 and 1 plus nothing will give us 1. So to form the next number, x raised to the power 4, we have nothing plus 1 will give us 1. 1 plus 3 will give us 4. 3 plus 3 will give us 6. 3 plus 1 will give us 4. And then 1 plus nothing will give us 1. To form the next number, which is x raised to the power 5, we have nothing plus 1 will give us 1. 1 plus 4 will give us 5. 4 plus 6 will give us 10. 6 plus 4 will give us 10. 4 plus 1 will give us 1. 1 plus nothing will give us 1. And then to form the next one, x raised to the power 6, nothing plus 1 will give us 1, right? 1 plus 5 will give us 6. 5 plus 10 gives us 15. 10 plus 10 gives us 20. 10 plus 5 gives us 15. 5 plus 1 gives us 6. 1 plus nothing gives us 1. And so on and so forth. So if you look at it now, it's a triangle form, right? Where the next number is gotten by the sum of the preceding numbers, right? So we have 0, 1. For x raised to the power 0, we have 1, right? Nothing plus 1 gives us 1. 1 plus nothing gives us 1. Then the next one, to form 1, 2, 1 now, we have 1. Nothing plus 1 gives us 1. 1 plus 1 gives us 2. And 1 plus nothing gives us 1. To form the value, the coefficients for x raised to the power 3, nothing plus 1 gives us 1. 1 plus 2 gives us 3. 2 plus 1 gives us 3. 1 plus nothing gives us 1. Now, to form the coefficients for x raised to the power 4, we use that of x raised to the power 3. Nothing plus 1 gives us 1. 1 plus 3 gives us 4. 3 plus 3 gives us 6. 3 plus 1 gives us 4. 1 plus nothing gives us 1. To form the coefficient for x raised to the power 5, we use that of x raised to the power 4. Nothing plus 1 gives us 1. 1 plus 4 gives us 5. 4 plus 6 gives us 10. 6 plus 4 gives us 10. 4 plus 1 gives us 5. 1 plus nothing gives us 1. To form that of x, the coefficients for x raised to the power 6, we use the sum of x raised to the power 5, which is nothing plus 1 gives us 1. 1 plus 5 gives us 6. 5 plus 10 gives us 15. 10 plus 10 gives us 20. 10 plus 5 gives us 15. 5 plus 1 gives us 6. 1 plus nothing gives us 1. If we continue like that, to form that of x raised to the power 7, right, the coefficient for x raised to the power 7, all you just need to do is to add the values, the coefficients for x raised to the power 6, you'll get that of x raised to the power 7. To get that of x raised to the power 8, you add the coefficients of x raised to the power 7, you get that of x raised to the power 8. Continuous, 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 like that, up until you're tired. Any number you want to get to. Whatever number you want to find, right, just add the preceding numbers, you get the values for that number. Right? Now, we'll find a way to bring this, right, into our set. into finding the subset of a set. Now, let's start by defining what a set is. A set is a collection of well-defined objects. Emphasis on well-defined objects. You can check our preceding videos on YouTube, right? I've done a comprehensive teaching on sets. Please revert back to our teachings on sets. You'll get the definition. You get more understanding on sets very well, right? And then, so what is a subset of a set? If a set is a collection of well-defined objects, what then is a subset, right? You say given two sets, A and B, right? Now, A is said to be the subset of B if and only if B contains the elements of A and also some more elements that are not in A. So let's take, for example, A is equal to A, B, C, D, for example, and B is equal to A, B, C, D, E, right? Now, A is a subset to B because if you look at B, B contains the elements of A, which are A, B, C, D, and at least one element that is not in A. So then A is said to be a subset of B. Now, a subset only happens between two sets, at least two sets, right? Now, but then you could be given a single set and then you are asked to find the subsets in that set. What does that simply mean? It simply means that form another set in that one single set that will be a subset of the main set. So if I have, for example, A equal A, B, C, D, right? Of course, if we are asked to find the subsets in the set A, it simply means that I need to form sets from the set A, right? That will then be a subset of the main set from A, of the main set A. Now, what does that simply mean? Of course, remember that every set, any set is represented by a capital letter, but the elements of a set are represented with a small letter. Please revert back to my teaching on sets and then you'll get a better understanding. So let's form more sets. Now, we can form sets from this set A. For example, the set B is equal to what? A. If we pick only element A, for example, right? B is a subset of A because element A is found in the set capital letter A, right? And there are B, C, D in A that is not in B. So other elements of A are also subsets of the set A. For example, the set C equal to element B, right, is also a subset of A. The set D equal to element C, right, is also a subset of A. The set E equal to element D is also a subset of what? A. Now, having picked each element, we can also form more sets from the set A. Now, how do we form more sets from the set A? By mapping each element to other elements, right? So, for example, we can have the set F equal to, for example, map element A. So let's map element A with every other element. We have A, B, right? First, we have AC, right? We have AD, right? So now, when we marked element A with each element one first, we had AB, AC, and AD. Now, we can still map element A with other elements to form three sets, right? Three elements. To form a set with three elements, all you just need to do, right, at this point, instead of coming back to the main set to start mapping to say A, B, C, A, B, D. So what I do is that when I mark element A, one pair, right, to form two pairs, I use these two pairs to form my three pairs. Now, this is A. So it is A that I used to form, that I mapped to form AB, AC, AD, which are my two pairs. Now, I use these two pairs to form my three pairs. How do I do that? I have I equal to, now, AB now. So I now make AB as my first element, then AB to C, and now C. Now, I did not do AB, I did not start mapping AB to ABCD. Reason because in a set, an element cannot happen twice. If an element occurs twice in a set, it makes the set not to be well defined. Remember from the definition of the set I gave to you, I said a set is a collection, not just a collection of anyhow object. It is a collection of well-defined objects. It has to be well defined, right? So if I map AB to A, I will have AB A, right? And then we'll have element A occurring twice. The same thing if I map AB to B, I will have ABB, which will mean that element B will occur twice. So what do you then do, right? To map AB, you don't map with the numbers that have appeared in the set. So you just map forward. AB to C, AB to D. Now, AC now, numbers are behind, so just map forward. AC to D. AD, you can't map with numbers behind, so you can't map AD to form three pairs. So the same thing, to form four pairs, we use our three pairs to form four pairs. To form five pairs, we use our four pairs that we had formed to form five pairs. The only difference is when you are forming a pair, you don't form backward, you form forward, right? Because if you form backward, it will mean that an element will occur twice. But if you are forming forward, an element can never occur twice. So now, if with AB now, AB cannot map backward, so we have S, A, B, C, right? And then the next one will be A, B, D. How do we then bring Pascal's triangle into finding the subset of a set? Okay, so remember that the total number of subsets that can ever be found in a set is 2 raised to power n, where n is equal to the number of elements in that set. Right? So if I have, for example, A equal to A, B, C, for example, the total number of subsets that we can ever find in this set is 2 raised to power. How many elements do we have? 1, 2, 3, which is 3, and that is 8. So it means that when I begin to map my elements in pairs, I'm going to get 8 subsets in total. Now, to make it easy and simple for us to be able to use Pascal's triangle, what I do is for element C, I give it 2 raised to power 0, element B, 2 raised to power 1, element A, 2 raised to power 2, right? Which means that if I map element A, I will get 2 raised to power 2 number of subsets, which is equal to 4 number of subsets. When I map element B, I'll get 2 raised to power 1 number of subsets, which will give me 2 numbers of subsets. If I map element C, I get 2 raised to power 0, which is what? 1, right? Which means when I map element C, I will only get 1 subset. Now, that's 1 plus 2, 3, 3 plus 4, 7, but we need, the total number of subsets must be 8. So remember that the empty set is the subset of every set. So we just know that the empty set is also 1, right? It is a subset of every set, which is 1 plus 1, 2, 2 plus 2, 4, and then 4 plus 4, 8, which makes us to have 8 number of subsets from this set of 3 elements. So if I have a set with 4 elements, say A, B, C, and D, for example, right? The total number of subsets that can be found in this set is 2 raised to power 4, 4 being the number of elements in the set, which is equal to what? 16. Now, the same way, D, the last number, the last element, 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3. When I mark element A with every other element, I have A will give me 2 raised to power 3 number of elements, which is equal to what? 8. When I mark element B with every other element, I get 2 raised to power 2 number of elements, which is 4. When I mark element C with every other element, I get element 2 raised to power 1, which is equal to 2 number of subsets. The same thing D, 2 raised to power 0, which is equal to 1. And of course, the empty set will give me also 1 number of subsets. So we have 1 plus 1, 2, 2 plus 2, 4, 4 plus 4, 8, 8 plus 8, 16. If I have 5 number of elements, let's say 1, 2, 3, 4, 5, or let's even make it 6, right? Now, of course, the last number, 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, and 2 raised to power 5, right? Now, what does that simply mean? It means that when I mark element 1 with every other element, I will have 2 raised to power 5 number of elements, which is equal to what? 32. 32 number of elements. Of course, the total number of elements that can be found, the total number of subsets that can be found in the set B is 2 raised to power 6, which is equal to what? 64, right? So now, when I mark element 2, I will have 2 raised to power 4 number of subsets, which is equal to what? 16. When I mark element 3, I will have 2 raised to power 3 number of subsets, which is equal to what? 8. When I mark element 4, I'll get 2 raised to power 2 number of subsets, which will give me 4. When I mark element 5, I'll get 2 raised to power 1 number of subsets, which is equal to what? 2. When I mark element 6, I'll get 2 raised to power 0 number of elements, which is equal to what? 1. And then when I mark, of course, the empty set will give me 2 raised to power 0 also, which is equal to what? 1. So if you add them together, we'll get 64. 1 plus 1, 2, 2 plus 2, 4, 4 plus 4, 8, 8 plus 8, 16, 16 plus 16, 32, 32 plus 32 gives us 64. Now, how do we then bring Pascal's triangle into this? Now, when we are mapping element 1, the index for element 1 is 2 raised to power 5. So at this point, our x is 2, right? While the index is what? 5. So it means that we are going to be using, for element 1 now, we are going to be using the coefficients of x raised to power what? 5. Now, what does that mean? Remember that when we formed our elements, right? When we marked element 1, we have them in pairs. We have first 1 pair, right? The same element, first element gives us, we use 1 pair to get 2 pairs. And then 3 pairs then we have use 2 pairs to get 3 pairs. And so on and so forth. Binomial expansion, right? Or binomial theorem, right? Pascal's triangle is used to find the coefficients of the variables, right? But then, in subsets of a set, Pascal's triangle is used to find the number of pairs. Now, 1 raised to power 5. First, how do you know which of the Pascal's triangle you are using is the index that is given to each element? So for element 1, we have 2 raised to power 5, which means we are using the fifth what? the which is the sixth index, which is x raised to the power 5, the sixth line of Pascal's triangle. And what does that mean? It means that my one pair will give me one number of subsets, right? Now, when I use my one pair to form two pairs, it will give me 5 number of subsets. Now, my 3 pairs will give me 10 number of subsets. Then the next one, 4 pairs, will also give me 10 number of subsets. Now, the next one, 5 pairs, will also give me 5 number of subsets. Then the last one, 6 pairs, will give me 1 number of subsets. So 1 pair gives me 1, 2 pairs gives me 5, 3 pairs gives me 10, 4 pairs also gives 10. If you sum all of them together, you will get 32. 1 plus 5, 6. 6 plus 10, 16. 16 plus 10, 26. 26 plus 5, 31. 31 plus 1, 32. We have an example. Find the subsets of the set A equal to the elements, to the set of elements A, element B, element C, element 1, element 2. Now, the total number of subsets that can be found in sub A, in set A, is 2 raised to the power 1, 2, 3, 4, 5, right? Which is equal to what? 32. Which means that we will find subset 32 subsets from this set A. Now, if we begin to map each subset, each element rather, element A will give us 2 raised to the power 5. That is from the last one, 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4. Sorry, element A gives us 2 raised to the power 4, right, which is 16 subsets. Element B gives us 2 raised to the power 3, which is 8 subsets. Element C gives 2 raised to the power 2, which is 4 subsets. Element 1 gives us 2 raised to the power 1, which is 2 subsets. And then element 2 gives 2 raised to the power 0, which is 1 subset. And of course, the empty set also is 1 subset, right? To map element A, which is the first element, right? 2 raised to the power 4. We use the we use the Pascal triangle x raised to the power 4, 2 raised to the power 4, x raised to the power 4, which is equal to what? 1, 4, 6, 4, 1. Which means we have 1 pair will give us 1 number of subsets. 2 pairs will give us 4, right? The next one is 3 pairs gives 6. 4 pairs gives 4. And of course, we have 5 pairs, which is equal to what? 1. Now, you know the number of pairs that you will get in each element by counting the number of expansion. 1, 2, 3, 4, 5, which means we have 5 pairs. The first one for the first pair, the second one for the second pair, the third value for the third pair, the fourth value for the fourth pair, the fifth value for the fifth pair. Now let's begin to map element A. So of course, we have A already, so we have B now. Or let's even remove this. So we have 1 pair for element A. We are mapping A. So we can only have 1 element, right, in 1 pair. Now 2 pairs, right? We use A, we map A to every other element without going back. So we have AB, right? We also have AC, we have A1, and then we have A2, right? So that's for 2 pairs. If you count it now, we have how many? 1, 2, 3, 4. 4 subsets. So it is complete. Now, to get 3 pairs, we get 3 pairs from 2 pairs, right? So we have 3 pairs now. Map AB to every other element, but never go back. So AB will continue from C downward. So we have AB, C. We have AB, 1, and then we have AB 2, right? Then the next one, AC, without going back. So it means that we have 1 and 2. So we have AC 1, we have AC 2. Now, the next one is A1. We can't go back. So just have A1, 2. A1, 2. The next one is A2. So we can't go back. So just that's all. So if you count it, we have 1, 2, 3, 4, 5, and 6, which means it is complete. Now, for 4 pairs now, right, we use our 3 pairs to form 4 pairs. So we have ABC now. Remember, we can't go back. So we have ABC 1 and 2. So we have ABC 1 first, and then we have ABC 2, right? The next one is AB1, 1. So we can't go back. So we move forward, which will be AB1 and 2. So we have AB1, 2, right? The next one is AB2. We can't go back, so we can't use AB2. The next one is AC1. So 1, we can't go back. So just have AC1 and what? 2. So we have AC1 and 2, right? So that's all. So the next thing, we have AC2. AC2, we can't go back. A1, 2, we can't go back. So that's all. If you count the 4 pairs, you have 1, 2, 3, 4, which is 4 number of subsets. Then of course, 5 pairs, which is the last one, is equal to what? ABC 1, 2, which is the total number of elements. If you look at it, ABC 1, right? Using 4 pairs to form our 5 pairs now, we have ABC 1. We can't go backwards, so we have just 2, and then which is 2, right? Now, ABC 2, no, we can't go back. AB1, 2, we can't go back. AC1, 2, we can't go back, which means we can only find one number of subsets in 5 pairs, which is what we have. If we count everything together, you will get our 16 number of subsets, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 1 pair, 16. Element B is 2 raised to power 3. So we'll be using the line of Pascal triangle x raised to power 3, right? Which is 1, 3, 3, 1. Yes. 1, 3, 3, 1, right? Okay. So now it simply means that one pair will give us 1 subset. 2 pairs will give us 3 subsets. 3 pairs we also give 3 subsets. Then, of course, 4 pairs we then give 1 subset, right? If you calculate everything together, you still get 2 raised to power 3, which is 8. 1 plus 3, 4, 3 plus 4 plus 3, 7, 7 plus 1, 8. Now, so we begin to pair. Of course, 1 pair is equal to the set D. So we are mapping B now. So 1 pair will give us B, because there can only be 1 B in a pair. 1 B in the elements of the set A. So now, we now map B with every other element, mapping forward, not mapping behind. So we have elements. So for 2 pairs now, we have B to C, right? We have B to 1, and then we have B to 2, right? So 2 pairs, we are done. How many subsets? 1, 2, 3, 3. So for 3 pairs now, right? We use 2 pairs to form 3 pairs. So we have first subset BC, right? Right? And then BC, we can't go backward, but going forward. So we have BC 1, right? We have BC 2, right? The next one is B1. So we can't go backward and going forward. So we have B1, 2. And then the next one is B2. We can't go backward. So that's all. How many subsets? 1, 2, 3, 3. And then, of course, we have 4 pairs. which is the last one, right? So BC1, we use our 3 pairs to form 4 pairs. So we have BC1. BC1, we can't go backwards, so we just have 2, right? Now, BC2, we can't go backwards, so we can't use it. B12, we can't go backwards. So BC12 is the only element, subset we can form from 3 pairs, which is also what? 1 pair. If you count everything, we have 1, 2, 3, 4, 5, 6, 7, and 8, right? Now, for element C now, right, is 2 raised to the power of 2, which means we are using the line x raised to the power 2, which is what? 1, 2, 1. 1, 2, 1. It means that from 2 raised to the elements with element C, we can only form 3 pairs. First pair, right? The first pair will give us 1. The second pair, 2 pairs, will give us 2. And of course, the third pair, which is 3 pairs, will also give us 1. Right? So we begin to form first 1 pair, which is the element C itself, right? We get just 1 element, C. Remember, we cannot map backwards, so we don't have any business with B, A, and B. So we just map forward. For 2 pairs now, we have C1. And of course, C2. Right? That's all. So, here's it. 2 pairs, 2 subsets. Now, for 3 pairs now, right? We use 2 pairs to form 3 pairs. So we have C1, not going backward, we have C1, 2. Right? We have C1 and 2. C2, we can't go backward, so we can only form C1, 2 from 2 pairs. Which is what? 1, 2, 3, and 4. Right? So it's the part 2. Now, for D now, 1. Element 1 will give us, that's 2 raised to the power 1. So we are using the x raised to the power 1 line of Pascal's triangle, which is what? 1, 1. Right? So, which means that we can only have 2 pairs from element 1. We have 1 pair, will give us 1. 2 pairs will also give us 1. So, which means that for 1 pair, right, we'll get only element 1. Remember, we can't map backward. So, 2 pairs will give us element what? 1 and 2. 1, 2. So, we can't get 3 pairs from this. So, and of course, the set 2, right, is 2 raised to the power 0, which is x raised to the power 0, right? And that is 1, which means we can only get 1 pair, which is 2. And that is all. And of course, never forget that the empty set is also a subset of every set. And if you calculate everything, we would have gotten 32 subsets, which is the number of subsets that can be found in what? The element A, and which is the total number of elements of subsets in that can be found in the subset A. Now, the power set of A, denoted by P of A, is equal. Now, when we put all of these subsets, right, starting from the empty set, right, then the set from the mapping of A, right, AB, and so on and so forth. When we put all of the subsets, yes, they are subsets, which means they are also a set. For them to be, for is another set to be a subset of another set, it means the 2 sets are a set. And remember, a set must be put inside a bracket, separated inside a curly bracket, not just any other bracket, curly bracket, which is called set bracket, separated with a comma. So the power set of the set A is also a set, which means its elements must be put inside the set bracket, separated with a comma. But then the elements of the power set of A are the subsets of A. Remember, the subsets of A are also sets, which means that you must enclose them also in set brackets, but they are now in the big set brackets, which is the mother set now, right? Now, when you enclose all the subsets of A in another set bracket, then we already formed the power set of A. So the power set of a set A, for example, of course, the power set of B will be P of B, right? Which means we have B here, right? Power set C is PC. Power set D is PD. But for our own example, we have the set A, right? Which means the power set of A is a set which contains all the subsets of the model set A. I hope you enjoyed the class. See you in the next class. Don't forget, Golden Maths Quest happens every Saturday, where 2 students will be able to win 5,000 naira each for themselves if they are the first 2 people to answer our questions correctly. I'll see you on Saturday. I'll see you in the next class. Thank you.